On February 15, 2026, the US military made history. They loaded the reactor core and the rest of a 5-megawatt nuclear plant into 3 C-17 Globemasters and then flew it from California and delivered it to Utah. But here are 2 things they didn't tell you. First, this is not a plug-and-play system. There is concrete evidence that after delivery and assembly, at least an extra 3 million lb, or 1,300,000 kilograms worth of materials, are still required to be shipped on-site before the reactor can be turned on. And second, what's being advertised as a cutting-edge portable microreactor is not even a new concept. In the 1960s, the US Army had already developed microreactors that could be flown on the C-100 Hercules. In fact, one of those reactors powered a top-secret project in Greenland that operated under the Arctic ice cap. But why is the US government suddenly interested again in microreactors? Well, it has to do with Alaska, Afghanistan, and Greenland, but its war tech, Vanguard, the most powerful air force in the world, still relies on coal to generate electricity. This 70-year-old coal-fired power plant is the primary energy source at Eielson Air Force Base, a military installation located 110 miles south of the Arctic Circle in a remote part of Alaska. There is a local coal mine near the base, which makes it a much cheaper fuel source than diesel. Also, in addition to electricity, the heat generated from the coal is what heats up the facilities during cold winters. Adversaries like Russia, leveraging nuclear power in remote areas, like Academic Lomonosov, the first commercial floating nuclear power plant in the world that powers the Arctic port town of Pevek. It can produce enough power to support a city of 100,000 people. So it shouldn't be surprising to see the US Air Force investing to augment this coal plant with a portable nuclear reactor in the coming years. But this is just a pilot project at home. The real driver behind portable nuclear reactors is to support the troops in forward bases that are far from home. But why replace diesel, which is cheap and simple to use, with micronuclear reactors that are expensive and sophisticated to run? Well, as it turns out, delivering diesel fuel to the battlefields is way more expensive than you think. But having an AI assistant is now easier than ever before, thanks to our sponsor, Claude AI. The Claude Note Pro is the world's most advanced AI note taker, and the only one in the world that can bridge in-person conversations and online meetings. Imagine having an assistant that speaks more than 100 languages and can connect all your conversations from the past 3 months, answer your questions, and provide insights. And if you're mostly out and about, then Claude Note Pins can record your conversations at a push of a button. You can wear it on your wrist, or clip, or pin it to your clothes, or just snap in place magnetically. My preference is to wear it around my neck. Why not use your smartphone, you ask? Well, the Note Pin has 40 days of standby time, 20 hours of continuous recording, and doesn't get interrupted when a phone call comes in. Both the Note Pro and the Note Pin can generate structured notes, whether you want a summary, a list of follow-up tasks, or a to-do list. There are 300 minutes of free AI transcription included each month, which means most people don't even need to pay a subscription fee. So say goodbye to note-taking and grab yourself a Note Pro or Note Pin using the links below for an exclusive discount. In 2009, United States Marines in Afghanistan ran through some 800,000 gallons of fuel per day. That's a massive fuel bladder being unrolled, although this particular one is used for jet fuel. At the time, the Pentagon bought fuel for $2.19 a gallon. By the time it reached a base in Afghanistan, it cost $6.39. For troops at remote outposts, the cost went up to nearly $12 per gallon, and in extreme cases, when fuel bladders had to be loaded into C-130s, filled up, and then flown out to the Marines, the cost went up substantially to a couple of $100 per gallon. But the true cost of getting diesel to the troops was paid with blood. What I'm about to say is truly shocking. According to a 2009 article published by Forbes, fuel convoys accounted for nearly 50% of all Americans who died in Iraq and almost 40% of deaths in Afghanistan. That's because these bases relied on continuous delivery of fuel to sustain their operations, and the fuel convoys used long, predictable routes on unsecured roads filled with wide. Even if that 50% figure is somewhat exaggerated, it still suggests that a staggering number of casualties in wars are caused not during active combat, but simply when driving trucks. This was a big enough issue that President Trump mentioned it just hours after the attack that killed Iran's supreme leader in February 2026. Acts, we are going to ensure that the region's terrorist proxies can no longer destabilize the region or the world and attack our forces, and no longer use the wide or roadside bombs, as they are sometimes called, to so gravely wound and kill thousands and thousands of people, including many Americans. The fuel supply issue becomes a much bigger problem when you realize that future conflicts will rely heavily on unmanned platforms and energy-hungry weapon systems. This would directly translate to more fuel convoys and consequently put more American lives at risk, which is exactly why the Pentagon is looking at nuclear batteries the size of a walnut that can release the same energy as 520 gallons of diesel. Nuclear energy gets a bad rap because of incidents like Chernobyl and Fukushima. But you can actually package uranium into an extremely heat-resistant fuel called TRISO, which can eliminate nuclear reactor meltdowns. To manufacture TRISO fuel, first uranium is dissolved into a special solution, which in turn is dispersed into an oil bath to create tiny spheres. These soft gel kernels are just a few millimeters wide. After being cleaned and drained, the kernels are then coated with engineered ceramic layers using chemical vapor deposition. This is done inside a chamber where different layers of ceramic are evenly built on top of the gel. During a sorting process, only high-quality spherical particles of a specific size make it to the next round. The TRISO particles are then poured into empty shells and packed with silicon carbide powder. To densify these fuel cells, they are loaded into a high-pressure chamber where they are exposed to special gases over multiple days. This is what the finished product looks like. Even if the reactor cooling fails and the core overheats, each TRISO fuel cell has its own containment barrier with an extraordinary high temperature stability. Now, here's the kicker: TRISO fuel isn't new either. It was invented back in the 1950s, but it was never really used industrially. TRISO was a more expensive fuel source used in high-temperature, gas-cooled reactors, as opposed to the traditional light-water reactors that are now prevalent. And after the 3 Mile Island accident in 1979 in the United States, and the Chernobyl nuclear disaster in 1986 in the Soviet Union, nuclear construction in the US essentially stalled. But in March 2020, while Americans were panic buying stockpiles of toilet paper, the US Department of Defense awarded 3 contracts to design and build a nuclear power reactor that could fit inside 4 standard-sized containers. so they can be easily moved by standard means of transportation. They called it Project Pele. And since the last thing the US military wants is a nuclear meltdown incident at one of their forward bases, the new reactors under Project Pele are powered by TRISO fuel. That said, the reactor's radiation emissions still need to be contained. And part of that is a 3 million lb shield, made up of 143 concrete blocks, each 78 inches thick. This allows the shield to be prefabricated and then transported on site. In case you're wondering, there's a very important reason why each block has that zigzag pattern on it. Gamma radiation and neutrons travel in a straight line. So to contain them, the concrete block will be rotated 90 degrees and then stacked on top of each other. This could create a 4 mm gap between blocks, but the zigzag pattern prevents any radiation from having a straight path to the outside world. But nothing could have prepared the US military for what happened to their micro-nuclear reactor in Greenland almost 70 years ago. In 1959, the US Army began building a series of tunnels under ice in Greenland for a scientific research station called Camp Century. They dug trenches with special machines and covered them with steel roofs in order to create living spaces for the crew. They even brought in the world's first truly portable nuclear plant, the PM2A, and set it up to power the whole complex. This was a traditional water-cooled reactor. Up until then, the team had to bring in thousands of gallons of diesel fuel on sleds. Interestingly, all of this work was documented by the Americans themselves and then publicised to the world, which is why the footage you're seeing exists in the first place. But, of course, this was all a lie. More than 30 years later, top-secret documents were declassified by the United States, and it turned out Camp Century was just a cover story to practice the techniques to build a 2,500-mile network of tunnels under ice. To hide 600 portable nuclear missile launchers that could hit the Soviet Union at a moment's notice. The real operation was Project Iceworm. But the US military engineers miscalculated one thing. The ice caps started moving faster than anticipated, and within a few years, the camp's tunnels were getting crushed. So they packed up the reactor and abandoned the base in 1967. The technology to shrink a sun into a shipping container has existed for almost 70 years. So airlifting a micronuclear reactor in 2026 may not be that revolutionary after all. But if Project Pele and its successors, like Project Janus, managed to keep those fuel convoys off the road, microreactors could become one of the most practical and life-saving tools that the US military has ever delivered.